Hi students, welcome back to Appleby Academy's classes. So in this video, we are going to discuss about the topic queuing theory. So we are actually discussing this particular topic under the module of operation research. So when you're taking this particular topic, operation research, there are different techniques which you need to study under this particular topic like PERT, CPM, then queuing theory, transportation problem, all these are important, and from these areas like from transportation and queuing theory, from these areas you can actually expect some problem questions also. Okay, so today we will be concentrating on this problem area from this queuing theory. Let's take a question which got asked for December 2021 and June 2022 merge cycle. Customers arrive at a reception counter at an average interval rate of 10 minutes and the receptionist takes an average of 6 minutes for one customer. The average queue length is. So here it is given the information related to how the customer or the average interval rate of the customer who is arriving at that particular receptionist and the time which is taken for each and every customers is given here, and based on this you need to calculate the average queue length. Okay, so we have a number of equations related to this particular area in order to compute a queue length or the average number of system. Like a way, we have a number of equations connected to this particular area. So if you know the equation very well, it is very easy to answer this particular question. Okay, so before going to do this particular problem, you should know what is a queuing theory. So what do you mean by a queuing theory? Queuing theory is one of the important application of an operational research technique. So when you're dealing with queuing theory, it is actually dealing with queue. Okay, so we know that when you are going to a particular if you're going to a theater or if you're going to getting some services in bank, in all these situations we are getting into some queue, right? So in that we are taking some time for standing in that particular queue and for getting the service from that particular person. Also we are taking some time. So this queuing theory is actually focusing on reducing this time, how we can reduce this time and how we can make it some more efficient. Okay, so that we are actually discussing under this particular theory. It's a study of movement of people, object or information through a line, not only about people but also about some object or information, whatever. So the queuing models are very helpful for determining how to operate a queuing system in most effective way if too much service capacity to operate the system involves excessive cost. So if you are using a particular method or a particular strategy, you can actually reduce the cost which is associated with a queue, or you can actually make a cost efficiency or time efficiency. So by using this particular theory, it is easy for you to find out the time which is the efficient time which is needed for a particular queue to get service like a way. So that we are actually discussing under this particular topic. Now we are going to discuss some of the equations related to this particular area, and we will do it. discuss the major equations from this particular area, that is from queuing theory. So firstly, it is about calculating average number of units in the system. So the term system means it is including the time which is required for the time which is you are in that particular queue, plus the time which is required for you to get the service. Okay, like a way, if you are waiting in the queue for 2 minutes and for service you need other 3 minutes. So that total 5 minutes is included in the system. Okay, so average number of units in the system is calculated by, this is the format, you can use ELS S4 system, which you can, the equation is lambda divided by mu minus lambda. Lambda divided by mu minus lambda. Moving to next equation, average number of units in the queue. Now, firstly we discussed about system and now it's about queue. So, if it is about queue, will represent as LQ and the average number is the lambda square divided by mu multiplied by mu minus lambda. And if it is about time, so here we discussed about the number of units, and if it is about time that we need to spend in system, we will represent it as WS, that means waiting in system, which is represented as 1 minus mu minus lambda, 1 divided by mu minus lambda. And finally, if it is about the time a unit spent in the queue, we will discuss as waiting for queue, which is represented as lambda divided by mu multiplied by mu minus lambda. So, all these 4 equations are very, very important. You should not skip these 4 equations, okay. So, there are other equations also, but when you are just taking the equations, these can be considered as the major equation which you need to study under this particular topic. Okay, so when you are taking the term, you got this lambda, mu. What do you mean by this lambda and mu all? So, lambda is actually about the arrival rate and mu is saying about the service rate, okay. So, lambda is arrival rate and mu is service rate. So, now we know the major equations relating to this particular queuing theory, and also we know that what does the term refer for. Okay, that is lambda is for arrival rate and mu for service rate. So, when you are just doing the problem, it will give you more clarity related to this. Okay, so in our question, it is about calculating the average length of the queue. Okay, so average length of the queue means it is about the number of units. Okay, how many units are there in that particular queue, that is actually we are considering, right? So, when it is about asking about average queue length, you can actually take this particular equation. So, the equation which we need to use for this particular problem is this one, the second equation, that is lambda square divided by mu multiplied by mu minus lambda. So, now we can just do the problem. Okay, so now just read our question. Customers arrive at a reception counter at an average interval rate of 10 minutes. So, the arrival rate is 10 minutes, okay, and the receptionist takes an average 6 minutes for one customer. So, the service time, okay, so the time which is spent for a particular customer is 6 minutes, okay. So, which is mu, mu is 6 minutes and lambda is 10 minutes. So, now we know that both these given in minutes, right. So, we need to consider for an hour how much people will come to that particular queue and how much people can be or for how much people you can give your service. So, in order to get this into or in order to convert these into an hour base, you need to divide 60 divided by 60 means for 1 hour you have 60 minutes, right. So, 60 divided by 10, and what about mu here? 60 divided by 6. For 1 hour how many or by 1 hour how many people can be given service by this that particular sender or by the receptionist, and by 1 hour how much people will arrive there. Okay, so 60 by 10 and 60 by 6. Okay, this is the way how we will convert. 60 by 10 means which is 6 and 60 by 6 means which is 10, right. So, the value which we needed for calculating this lambda and mu, lambda is actually 6 and mu is actually 10, right. So, now we can actually calculate the problem. So, we know that the equation, that is average queue length, is calculated by the equation lambda square divided by mu multiplied by mu minus lambda. And what about lambda? We already calculated the lambda is 6. Okay, that is for that is a average time which is 4 per hour, right? So lambda square means 6 square. So you can write 6 multiplied by 6 divided by mu. What about mu, which is 10? So 10 minus 6, right? So how it will be? 6 6 are 36 divided by 10 multiplied by 10 minus 6, which is 4. So 10 into 4, which is 40. Okay, so now you can cancel this with 4, right? So when you are just taking 4, you will get 4 9s are 36 and 4 10s are 40. So your value will be 9 by 10. Okay, so the correct answer for this question is 9 by 10. So now we discuss queuing theory. So now it will be little bit easy for you to know how you will calculate the various problems based on how you will find the equation based on given situations, and how you can calculate lambda, mu and all. So do practice this question again and again. Then only it will be easy for you to calculate the question from this particular area. The only thing is that you should know the equation from this particular area, and also how to calculate or how to find the value for lambda and mu only. Then it is very easy for you to calculate question from this area. So don't skip this particular area, which is very important. For the next exam, you can expect again question from this particular area. So do practice. Thank you and happy learning.